What is up, Flutter devs? In today's widget workshop, we're going to be building an image flip effect. Given a set of images and a single image display, when we switch from one image to the next, the image display is going to do a 3D rotation to reveal the next image. It's a neat little bit of eye candy that really grabs the user's attention when the image changes. Now, as always, if you like what I'm doing on this channel, if you enjoy the content, go down and hit that red subscribe button if you haven't already, give the video a thumbs up, and share the message of Flutter with coworkers and colleagues, and let's get the word out there. With that, let's jump into the workshop. Today we're going to build an image flipper. That's an image that flips to reveal the next image as you switch between images. And as always, we're going to begin here with this black rectangle, and this black rectangle will be replaced with our image flipper. The first step for us in getting to that image flipping effect is to define the widget that will eventually have that effect. We're going to create a stateful widget called flipping image, and flipping image is going to bring in an asset path. You could do this with a URL instead of an asset if you'd like. You just need to think a little bit about preloading URL-based assets or URL-based images, because it can take a second or two to load an image, and that is not going to play well with this effect. So that's a wrinkle for you to figure out if that's what you want to do. But we're going to work with assets, and in fact, I already have code, I think, that preloaded them, so we're going to avoid the loading issue. We just want to work on that flip effect. But before we can get to a flip, we need to actually display the image how we'd like. So we have this container here, and we're going to place a center within the container, and then we're going to introduce a clip R rect, which is going to give us rounded corners on our image. We're going to use a border radius, a circular border radius of 16. And then we are going to introduce an intrinsic height, which will make the height of our widget determined by the natural height of our image. And finally, we will have an image.asset based on the asset path that is passed in. With that little subtree set up, we'll come back up here into our workshop scaffold, and we will replace our black box with a flipping image. And we will pass in an asset path. And where did that come from? It's given to us. So I've already written some code that has a series of images preloaded, so we don't have to worry about dealing with images. We just want to focus on the flipping effect. Let's save that. You'll notice over here, my beautiful face, lots of yellow. These images here are the thumbnails from various other widget workshops. Those are going to be the images that we're working with. But as we switch from one image to the next, instead of just showing the next image, we want to flip the image around. The old image flips behind and the new image is displayed. That's the effect that we're going for. This was step one. This was just getting us set up. And in the next step, we're going to begin to explore the issue of rotation. Now let's look at how we accomplish rotation. We're just going to play a little bit with it in this step. We're not going to worry about animation yet. Let's just look at the most fundamental level how we achieve the illusion of three-dimensional rotation in Flutter. Down here in our widget tree, we are going to, above this clip rect, we are going to introduce a transform widget. It's going to take a transform property, which is a matrix 4. Matrix 4s are always used for transformations in 3D space. They're all over the place in graphics. We're going to begin with the identity matrix. That just means don't change anything at all. But then we are going to update it with the set entry. These values you can copy, and you should copy 3, 2, 0.001. This represents a perspective matrix. There's a bunch of math behind why this matrix is relevant for transformations. You don't need to understand it. these first two values I think will always be the same for you. This is the value that you might change a little bit, and we'll play around a little bit with this in just a moment. But you're always going to have a value. So you're always going to have 3, you're always going to have 2, and then this number is always going to be a very, very small number, somewhere around 0.001. And this gives us a transformation that when we start doing rotations, it makes it look like you're actually rotating. So this is what allows the perspective transformation to take place. And then on top of this, we need to actually do a rotation of some kind. Just so, for example, let's save that, and nothing has changed over here. And we'll do a hot restart just to be absolutely sure. Nothing has changed. That's because what this matrix does, if we're just sitting flat in normal 2 dimensions, nothing changes. But when we rotate, this perspective matrix causes the rotation to actually distort the image to make it look like there's a third dimension. So in addition to setting up the perspective matrix, let's rotate along the x-axis, and we will rotate, we'll go 6/8 pi. Save that. Oh, there's one more thing that we need to do here. So it did distort it, but now it's off up at the top. The problem is we need to align to the center. We want to rotate about our center. And now we're back where we should be. So notice that we are rotated. We can go, let's say 1/8 pi. So let's start at 0. 0 is totally normal, right? Go 1/8, 2/8, 3/8, 4/8. Notice we can't see it. Why can't we see it? It's because we have, there's no thickness to our image, and we are exactly, I guess, perpendicular to the screen. But then if we go 5/8, well, now we're rotating around the other side. 6/8, 7/8, 8/8. We can jump back to 0. That's how rotation works fundamentally. We apply a transform widget. We set up a perspective matrix. And by the way, I'll show you a little bit about this value here. So let's go to 3/8 or something, or maybe 2/8. Let's change this to like 0.01. See how crazy that transformation is now? That's a ridiculous, it's like a fisheye lens kind of situation. Let's go 1/10 of what we had. And now there's barely any skewing at all. And then we go back to what we originally had, and I'm pretty happy with that. You can play with this number. You shouldn't get much larger or smaller than 0.001, or you're going to have some really weird effects. But otherwise, this line right here is always the line that you want. And after that, you do your rotations. And don't forget about alignment. If you don't align to the center, it probably aligns to the top left or something, and that's not really what you want. So that's the fundamentals of rotation. And in the next step, we're going to actually animate this rotation so we can move from one image to the next. Let's introduce some animation to our rotation and see what we can get in the way of a flipping effect. As with any animation, we need to begin with a ticker mix-in, and we need an animation controller. We need to set up that animation controller in init state. We'll pass in ourselves for the VSync. For the duration, we'll go with, for now, we'll just go with 2 seconds. It's a pretty long rotation. And of course, we need to dispose of the animation controller in dispose. Now let's come down here. We'll take our transform widget and let's surround it with an animated builder. And our image down here really doesn't change, so I think we can get away with putting that in the child slot. Then we need to actually calculate the rotation. And we'll go with pi times animation controller dot value. 0, of course, is no rotation. Pi is 180 degrees rotation. So those are the angles that we're playing with. And then down here in rotate X, we will pass in rotation. And for now, so we need some way to trigger the animation. For now, let's just come in here and override did update widget. We'll need to do some work in here later anyway. But every time the widget changes, or let's just say if the asset path changes, then we will tell our animation to animate from 0. So we definitely have an animated rotation, and that's a good start. Now the image isn't changing at the right time, and we are allowing the image to be inverted, and this animation curve is not very attractive, but this is clearly the basis for what we're going for. So let's just keep massaging it, keep working through it, and see where we can get ourselves. One thing that we need to deal with is the fact that we have multiple images. We're changing images. So we have a current image path. That's the image that we are displaying at a given moment in time. And then we have, you can kind of think of it as the current/old image, as well as the, let's say, the new image. Here in init state, image 1 is equal to image.assetPath, and the current image path is equal to image.assetPath. But then down here in did update widget, instead of starting our animation, we want to set image 2 to widget.assetPath, and then we do still want to rotate, but we'll put that in a local method called flipCard. So let's define flipCard, and we will say current image path equals image 1, just to be clear, and then rotation, or we'll say, sorry, animation controller, we will start from 0. And so the question becomes how we want to manage which image we show at a given moment in time. For now, we will define a method called onRotationComplete, where we will change out some of these images. We will say, we'll send the animation controller back to 0. We will make image 1 equal to image 2, and the current image path will be equal to image 2. Coming up here to our animation controller, we will add a status listener, and if the status is equal to complete, we will invoke onRotationComplete. And let's see what this gives us. So we're still switching the image at the wrong time. We'll need to figure that out. And we're flipping back to the original position at the end. So we're making some little incremental progress. Now, one thing that I want to change is I don't like this animation curve at all. The linear curve is no good. So let's create a curve, which is rotation curve, and we'll go elastic out. And then let's apply that curve down here where we calculate our rotation. We will transform our animation value with the curve. And let's also increase this duration to 5,000. So 5 seconds, which is a pretty long rotation. So I like that effect a lot better. It takes longer. You have to be in a situation where you have 5 seconds to wait. But in my mind, that's a much more natural effect. And I remember now that we introduced current image path, but I forgot to use it. So down here, instead of displaying the asset path, let's display the current image path. So now it actually waits all the way until the end, and then it switches it. Still not exactly what we want, but it retains the original image for longer, because we do need to at least retain the original image until we get to the halfway point. So we'll massage that in a future step. Right now we have a rotation animation. We have it on this elastic curve, so it goes back and forth. We hold the original image until we get all the way to the end. We'll continue massaging this and improving it in the next step. In this step, our goal is to figure out when to switch from one image to another. Currently, we're passing in the current image path. That causes us to show the original image until the animation is completely over, which is not what we want. So let's create a method called choose current image. And this choice is based largely on the rotation value. It's a combination of which image is considered the current image path and what the rotation is. So in here, if the current image path is image 1 and rotation, actually we're going to take in a rotation. This rotation here, this isn't the animation value, to be clear. It's not this value. It's this whole value. We need to apply the curve to it, and we need to turn it into an actual angle, and that's what we want to base our decision on. If we're greater than pi over 2, so here is an angle of 0, here is an angle of pi. This point right here where we go invisible, that's pi over 2. If we're greater than that, then the image that we want to show is the next image. So we start here with image 1, rotate, rotate, rotate. After we get to this point, now over here, we want to see image 2. So image 1, image 2. So if this is the case, we want the current image path to be image 2. So to be clear, this condition is the first image has crossed over to the second image. If the current image is image 2 and rotation is less than pi over 2, the second image is visible, but we've swung back to the first image. Now, why might this happen? If all we do is rotate like this situation never happens. But here's the thing. If we go past the halfway mark, but then we fling back, like if we use some kind of animation curve that really springs back and forth, we need to consider the possibility that we need to revert back to the previous image. Now, if we are actually showing image 2, we need to adjust rotation so that if we're showing the next image, we don't horizontally invert it. In other words, instead of showing the back of the next image, show the front. So that this goes to the problem that we saw before, where once we rotate beyond halfway, we get an inverted image. We don't want an inverted image. We want the next image to appear right side up. And so we actually need to adjust the rotation. So we actually have to alter the rotation. We have to subtract pi from it. We have to undo half of the rotation. Now, because we are adjusting the rotation, this really isn't an operation that we can do in the middle of our build method. So I think really what we want to do here is we want to actually have a variable called rotation, and we want to go ahead and keep this updated over time rather than calculating it inside of the build method. So let's add a listener here, and we will invoke update rotation. We'll go ahead and we'll call this update rotation. We'll come down here and we'll take this calculation. We'll move it right here. We'll make it a double. And so here, and actually, sorry, this should be rotation. And we can stick this whole thing in a call to set state, because once we update these values, we need to go ahead and redraw or rebuild the tree. Now, because we are basing rotation, because we're keeping track of rotation at the widget level now, we probably want to go back to what we had before, which was a single tree that always rebuilds. So let's undo some of this stuff here. Let's take this transform and let's replace the animated builder. And now we're back to having one overall tree, and we will just call set state every time rotation changes and every time current image changes, and that should be fine. But that allows us to invoke update rotation every time the animation changes, which allows us to reevaluate the current image. And it allows us to update rotation right here so that we don't invert the next image. Now with those changes, let's do a hot restart and make sure that things actually work the way we think they do. Okay, so notice that now the image is switching at the right time and it's not inverted. Oh, but those aren't, let's see, those aren't quite switching at the right time. So we still have an issue here with the timing. But in the case where I don't, in the case where I let it finish, it's okay. So the issue that we're facing here has something to do with me interrupting it. There are probably a couple ways that we could address this, but here's what we'll do. We will define a method called immediately finish current animation. We will say if animation controller is animating, then animation controller stop. Oops. Stop. Current image path equals image 2. That's the next image. And image 1 equals image 2. This kind of resets us for the next stage. and we will invoke that right here. Do a hot restart. So now no matter how rapidly I switch these, we pretty much look fine. So this is how you get a rotating image flip effect in Flutter using a widget tree, primarily driven by a transform widget with a perspective matrix. So I hope you learned something in today's widget workshop, and I will see you in the next one.